Hey, my name is Mike. I'm an engineer here at Readyset, and today I'm happy to announce that MySQL is now generally available in Readyset. And along with that also comes a brand new, fresh user experience for Readyset in our cloud platform. So today we're going to be going over connecting a Readyset cluster to a MySQL database, sending queries to that cluster, and showing that after we cache them, we can see up to 100 times performance improvement for slow running queries in MySQL. So what I have here is an RDS instance that I've already set up with a data set that tracks the IMDb ratings of various movies that have been released over the past few decades. And so there's essentially only really two tables in this database, one that tracks the names of all of the movies and one that tracks the ratings of said movies. And so what I want to do here is I just want to establish some baselines for some queries that we can run against this database to see how long they take before we cache them. So if I just run this rather slow not in query against the title ratings table where average rating is greater than 5, we see that it takes about 2 seconds to run this one. I have another one here where we're looking for a particular genre of movie, and the average rating is greater than a particular value we set again. And this one's taking about half a second. And then we've got another one that's doing an order by and setting a limit of about 100,000 rows. And so this one's also taking about half a second here. And so I just wanted to show that when we run the queries against the upstream database directly, we see a particular latency for the queries. And so now we're going to go ahead and create the Readyset cluster and show what happens when we just run the queries directly against the cluster before and after we cache them. So to create a cluster inside of Readyset Cloud, we will get to the Create Cluster page. We'll give it a name. We will select the region that our upstream database is already deployed into, which in this case is going to be US East 2. We'll select the cluster size, which is going to be based on our subscription. I'm going to go ahead and select a small cluster. Then we want to fill out the credentials of the database. We want to select MySQL. We want to provide the host, as well as the database name and the port that the database is running on. For the purposes of this demo, we're going to select public as our connection type. In a real production scenario, you would likely select VPC peering to peer with the Readyset cluster, or external to deploy into your own AWS account's VPC. We've also enabled some advanced features here for Readyset that will improve the performance of our caching results. And without further ado, we will create the cluster. So after some time, your cluster will come up and be replicating the data stream to your upstream database. And if we come over to the Ready to Cache page, we'll see that there's been no queries that have yet been proxied. So let's go ahead and connect to the cluster and send those same queries that we just sent before to the upstream database. So to connect to the cluster, we want to hit this Connect tab up here. This is going to provide us with some different ways that we'd be able to connect our application. For now, we're just going to connect over the command line. So we're going to go ahead and take the details from this MySQL connection string and connect in from our terminal. Okay, so now in our command line, we're going to connect to the Readyset cluster. And we're going to run those same 3 queries that we ran before to see the baselines once again. But now we're sending them to the cluster itself, not the upstream. And we see that the first one is, again, taking a little bit over 2 seconds to run. Run it a few more times just to see the duration of time it's taking. Let's run that second query. That one was somewhere between half a second or so and about 1 second. And we see we run it a few times. We're getting some consistent results here. And we run the third query, which was, again, I believe around half a second. Seeing 0.45 seconds. So this is around 570 milliseconds. So now after sending those queries to the Readyset cluster, when we come back into Readyset Cloud, we can see that we have 3 queries here that are ready to cache. And if we go ahead and cache all 3 of these queries, we'll see that they show up in the cache queries page. And now we can run the same queries again against Readyset and see how the performance has improved. So let's run that first query again. That was the one that had the not in statement, which was taking over 2 seconds. And we just needed to reconnect again. we see that when we run this query directly against the Readyset cluster, because it's cached, even though it's doing a very slow query, it's running in about 0.03 seconds. It's about 30 milliseconds down from 2 seconds, so 2000. So close to 100x performance improvement there. If we take the second query, which was just doing a where clause, again, we're seeing down to 40 milliseconds there. And if we take the third one, so keep in mind that this latency is also including the network hop to retrieve data over the internet. In a production environment, where your application is deployed in the same network as Readyset, you could potentially even remove some of the slowdown from the network hop. And again, some of these queries were only taking half a second, so you only saw maybe 10 to 20 times performance improvement. But for very slow queries, like the one that was running for 2 seconds, we saw close to 100 times performance improvement. It's not uncommon for us to see even greater than 100 times performance improvement for larger data sets and more complicated workflows. So there's one more thing that I wanted to demonstrate here, which is that Readyset will automatically do cache invalidation for you. So there's no need to implement cache invalidation or know when the backend data source has changed. So in other words, when data updates against your upstream database, Readyset automatically becomes aware of that through replication nearly instantaneously. So if I go ahead and run that original query that was taking 2 seconds. So on the left-hand side here, we have the RDS database connection. If we go ahead and run that again, we'll see that it's still taking 2 seconds, and it's returning 363,062 rows. And if we go ahead and run this over here, so this is the Readyset cluster, we see that it returns 363,062 rows, but it takes only 30 milliseconds. So now if we go ahead and perform an insert into this table, the title basics table. So if I go ahead and insert a new row into the title basics table, and then I go ahead and run the same query again against the upstream, it's still taking time, but we see that it now reflects the new row count. And without having to change anything, if I just run it against Readyset, we see that it immediately reflects the difference in the data. So again, with Readyset, there is no need to do cache invalidation. It is automatically taken care of for you. Well, that concludes our demonstration for today. Once again, MySQL is now fully live and in general availability on Readyset. And we invite you to sign up for a cloud account where you'll have access to a free trial and you can test out your workload. And lastly, we invite you to book a demo where we can answer any questions that you still might have regarding Readyset and also get the opportunity to drill into your specific use case. Anyway, that's all we had for today, and thank you again so much for watching.